Hi guys, welcome back. In this video I will solve this problem which is related to interfacing with microprocessor based system. Now I'm not gonna read this whole problem because it's quite a big, so to save you some time what you can do is you can pause the screen for a while and read it yourself. Nevertheless, I'm gonna explain some of the questions along the way. And just a quick reminder, if you haven't subscribed my channel yet, hit that subscribe button and that bell icon so that I can help you in programming, technology and engineering. Alright, with that being said, let's dive into the solution. I hope you have read the problem by now. So we have like 5 questions over here, and the answer of first 2 questions are pretty obvious. They are more or less like same in every problem. And also when you draw the mapping circuit, which happens to be third question in our case, so when we draw that, we'll have the answer of these 2 questions. So let's draw the mapping circuit. So this will be Vref, this will be ground, and while drawing mapping circuit, start with left hand side, because on the left hand side most of the things are same. So like A0 and then A1 and then reset and then data's coming from and to the 8255 ppi. So this will be D7 and D0, and here you can say from to 8285. Now the 2 things that you need to take care of on the left hand side are whether you should write memory read, memory write here, or input output read or input output write over here. And since this is memory mapped, we'll write memory read and memory write over here. So let's write that memory read, and this all will be active low signals, so memory write. Okay, and don't forget to draw a small circle over here, and then over here we'll have chip select, so let's draw that too. Okay, and here A2. Now when it is memory mapped, we'll have A2 to A15, but when it is IO mapped, then we'll have A2 to A7. And how can we identify that it is memory mapped or IO mapped? You can identify by seeing the address of port. See, the given address the given address is of 16 bits, so it is memory mapped. But if it is of 8 bit, then it is IO mapped, and in that case here we'll write IOR and IOW, and here we'll have A2 to A7. So we are done with this left hand side. Now let's move to right hand side. On the right hand side we'll use ADC to provide digital inputs to the 8255 ppi. So let's say ADC here, and we'll also use multiplexer. So let's draw that too. We are using multiplexer because we are supposed to process 2 different inputs, as you can see here, pressure and temperature. So we are using multiplexer. Okay, now to read any inputs, we need to have port. So we'll use port A. You can use any port, but by convention port A is generally used for reading inputs, so let's do that. So we'll say PA0 and then PA7 over here. And now you can use SOC, EOC or interrupt. And if in the question no information about SOC, USC or interrupt is given, then I will suggest you to use SOC, USC. So SOC and EOC. So SOC is given by PPI to ADC, and EOC is given by ADC to PPI, and SOC is generally assigned with PC naught, and EOC is generally assigned with PC 7. And what difference do we find when we use SOC, EOC and interrupt? So when we use SOC, EOC, the mode of port A will be 0, okay, and when we use interrupt, the mode of port A will be 1. So now we have used port A and port C. Let's move to multiplexer. So here we'll use only one bit of port B, and that will be PB0. And why only one bit of port B? Because we're only processing two different inputs, that is pressure and temperature. But if we have like say 16 inputs, then we'll use like 2 to the power 4 bits of port B, that is 2 to the power 4 equals to 16. So in that case we can process 16 inputs. So in that case we'll have PB0 to PB3. But since we are processing only two inputs and they are pressure and temperature, therefore this will be only one bit of port B, so, and that is PB0. So, and those two inputs are temperature and pressure, and then we need to draw like this. So this is the mapping circuit, okay, and since we are done with this mapping circuit, we can answer these two questions. So the answer of first question, that is list out the collected documents and component, is in document you can write these things: data sheet, technical and specific documents. You can memorize this. And in component you can see from your mapping circuit that we are using ADC, multiplexer, and then 8255 PPI. So these things you can write under the component section. And moving on, we have list out different signals you need to list out different signals you need to derive and or can be directly connected to your interfacing circuit. So as you can see that we have signals like chip select, A0, A1, memory read, memory write. So these are the signals that you can write in this question. So we are done with 1, 2, 3 questions. Let's answer the fourth question. Now we are already given base address and 5000H, and that base address is port A address. So let's write that. Okay, so first let me write 3 here, and then over here 4. So port A is equals to 5000H. okay, I hope you know the address of port B and C and control register by now, because in this last video I have already explained how to write port addresses. So if you haven't watched that, please go ahead and watch that. So we are also done with fourth question. Now the last question is write a program module for measuring temperature and control if temperature is not in the range. Assume suitable data if necessary. So we are only processing temperature here, not pressure. So keep that thing in mind before writing program module. Okay, now let's write the program module, that is simply program. So program, let's say over here. Actually, before writing program we need to have control word for setting the configuration of all the ports. So let's write the control word. So I should have drawn this a little wider, but anyway, 5, 6, 7. Now this will be 1 as always, and the mode of port A is 0, so D6 and D5 will be 0, 0 respectively, and D4 is port A, and port A is input, so we'll write 1 here, and then D3 is port C upper. Port C upper means PC7, and this is input 2, so we'll write 1 here, 2, and D2 is the mode of port B, so mode of port B is also 0 because of SOC USC, so we'll write 0 here, and D1 is port B, and port B is output as you can see here, so we'll write 0 here, and D0 is port C lower, and port C lower is PC0, and PC0 is output, so we'll write 0 here. So this, the control word is 98H. So 98 is the control word. Now let's write the program. Let's say program over here. Now we need to initialize a pointer to store the read inputs into memory. So for that, LXIH memory, and this is just a variable name. You can name it whatever you want, but name it something meaningful. And then we need to output the control word from control register. So MBIA 98H, 98 is the control word, and then STA 5003H, this is the address of control register, so 5003H, and since this is of 16 bit, we are using STA, but if it is of 8 bit, then we'll use out. And now we need to actually, after outputting the control word from control register, we had been setting or enabling SOC, but in this case we have two temperature we have two inputs, temperature and pressure. Okay, pressure and temperature, so we need to specify that which input we will be processing. So for that, MBI A00H and Y00H, because like I said, if PB0 is 0, then we'll select temperature for processing, but if PB0 is 1, then we'll select pressure for processing. So 00H. Now we need to output it from port B, so STA 5001H, this is the address of port B. Now we need to set or enable SOC, so MBI A01H, and I hope you know Y0 and 01H now, and then STA 5003H, we need to output it from control register. So we have output the control register from control word from control register. We have selected the temperature for processing, and we have enabled SOC signal. Now we need to check for EOC. So let's read input from port C, LDA 5002H, and then RLC for checking PC7, because PC7 is connected with EOC, so RLC, and then jump on 0 to loop. So if PC7 is 0, that is jump on 0. So if PC7 is 0, then we'll loop over here. We'll continuously check if EOC has occurred. In other words, if ADC has completed converting all of the analog inputs into digital inputs, and if it has, then we need to read input from the input port. So, and the input port is port A, so LDA 5000H, because 5000H is the address of port A. Okay, now we have read the input from port A. Now we need to store, so MOV MA, so we are basically transferring the read input from accumulator to the address contained by this variable. Now we have stored the variable, sorry, input. Now we need to check, we need to control if temperature is not in the range. Okay, so for that, CPI max val, okay, and maxwell is the variable, you can name it whatever you want again, and then jump on not carry to control. Okay, so if the input in the accumulator is greater than the value contained in this variable maxwell, then we'll jump to control subroutine program, and this is just a subroutine program which controls the temperature if it is not in the range. And then CPI mean val, this is also a variable which contains the minimum value of the range. Okay, so CPI mean val, and then jump on carry to control, and this is again the subroutine, same subroutine program, and then we can just stop the program HLT. So this is the program, and I hope you have learned something from this video, and if you have, then give it a thumbs up, and if you have any queries or suggestions related to this video, please leave it in the comment section. I'll try to reply you as soon as possible. So yeah, thank you for watching.